A projectile. So basically, when we're talking about a projectile, you are seeing a man trying to use a catapult, yes, to hit a bell. So this catapult process energy. So by the time it releases the energy, it moves in a what we call parabolic path. So it's not a straight path, it's a parabolic path to hit this particular one's bell. So when we're talking about projectile, we're talking about objects or a body launched into the air and allowed to move on its own or move freely under gravity. So many things happen here. So a projectile motion is one that follows a curve. That we call it a curve or we call it a parabolic path. Yes. And it is due to two independent motion. Yeah. Yes, which is right angle to each other. The horizontal. So basically when they say the horizontal, what they mean by the horizontal is this. So we have the horizontal, then we have the vertical. So is there are two motions involved here. The one that is horizontal. So the horizontal is moving with constant velocity, while the vertical is moving under gravity. Um, then what are the examples of this uh, projectile? So we have, okay, we have the first one here. We have an athlete doing high jump, as you could see here. So this man is trying to, this particular man you see here, what he's trying to do is trying to jump. So he's jumping in a parabolic manner to the water, or you have a stone release from a catapult, as you could see here. So his stone is being released from a catapult, or you have a bullet fire from a gun. So you can fire a bullet from a gun. Then you have a ball, yes, a thrown rubber ball rebouncing. So you discover that as the thing is, the frequency is reducing, the vibration is going down as it is rebouncing. Yeah,
Yeah.
this kind of motion, we call it a projectile motion. Their motion, yeah, yes, under two vertical and the horizontal motion. So one is horizontal. The horizontal is moving with constant velocity, while the vertical one is moving under gravity. So when you see such examples are projectile. And we'll be talking more
Yes.
about this as we move on with the class. So this is another example here. So when you see what we have here, yes, what you have here, you have a paper and you have a coin. So if they subject them under the same condition, where the air resistance is is uh, is negligible, then the paper and the coin will land on the ground at the same time. Why? Because they are under the same influence of gravity. So they are under the influence of the same gravity. So that's very, very essential. So when you have all body irrespective of mass have the same acceleration under what? Under the influence of gravity. So for this reason, they will both land to the ground at the same time. Yeah, and this was experimental or experimented by what we call Galilei, Galileo Galilei. So Galileo Galilei was the first to experiment this. And you see the way they subject them under the same gravity, irrespective of their mass. And they discovered the land at the same time. So they landed at the same time on the ground. Yes, and due to the what? Due to the same acceleration which boats have. So when an object is subjected under the same influence of gravity, irrespective of their mass, they are going to land to the ground at the same time. So you need to know, yes, at the same time, you need to know this as well. Look at these objects. So these are the objects. So this object is on the tower. So this object is being what? Yes, projected horizontally from the top of the tower. So it's projected horizontally from the top of the tower. Told you that it's under influence, two influence. The first one is the horizontal what motion. Yes, the horizontal motion is moving at constant velocity. And we have the other one, the vertical one that is moving, yes, under the vertical one that is moving under the what? Gravity. And this kind of motion, we can resolve it. Yeah, we can resolve this kind of motion. So we can resolve this kind of motion. So if you are to resolve this kind of motion, you need to note that if you have this as u, so you have this as u. So what I'm having here is going to be like this. So this u. So this, the vertical motion, we call it Vy. Then this, the horizontal motion, Vs. So if I resolve this along the horizontal component, so along the horizontal component, what I'm going to have here is, if this theta, so this be opposite, then this one become hypotenuse, while this adjacent. So if I consider so casual, if I consider so casual, now I have adjacent and you have hypotenuse, so I'll be considering what? Cos. And the cos in this direction will be cos theta equals to what? The adjacent, which is Vx over the what? The V, or over the U, and over the U. So the Vs basically will give me U cos theta. So that is along the horizontal component. And along this horizontal component, you need to understand that G is equal to what? O, because it's not under any influence. So for the vertical component, I'll be considering opposite and hypotenuse. So that is sine. So I'll be having sine theta equals to opposite, which is Vy over hypotenuse, which is U. So basically Vy in this category will give me what? U sine what? Theta. So this is a vertical component. And this vertical component is under the gravity. Yeah, it's under the what? Gravity. Yeah, it's under the what? Gravity. So in that particular order, but in this particular order, You need to understand that when you are resolving along the what vertical axis, the V becomes U sin theta, horizontal axis, U Vs becomes U cos theta. Then when the object is vertically projected, the initial U, the horizontal U will equal to zero before start changing. And when it reaches the ground, the V becomes zero. So you need to understand this as well, that when you have it at the top, so when you have it at this point, so when you have it at this point, yes, the horizontal component before coming down is zero, then begin to change. Then when it reaches the ground, then the V becomes zero. So you are going to see more of this as we move on with this class. You are going to see more of this. So if we go to the next, trying to make it respond. I want to switch it to the next slide, because it's not really responding. Okay, good. Okay, so let me do the cleaning for us. So in this place, what we need to do here is blocking it. So it is flying horizontally. So when it is flying horizontally, U is equal to zero. So horizontally with a constant speed. It is moving up and down with acceleration, which has to do with gravity. So when the ball falls vertically under the influence of gravity, its vertical motion is independent of the horizontal motion. Hence, its initial velocity is equal to is zero. So when the object is it's projected horizontal motion. When you say an object is horizontal, is projected horizontally, what comes to your mind is what? The initial vertical velocity is equal to zero. The initial vertical velocity is equal to what? Is zero. So hence, any projectile in flight is doing two things at once. It is flying horizontally with constant speed. It is moving up and down under the influence of acceleration. So when the ball falls vertically under the influence of gravity, its initial velocity is equal to zero. Okay, so you begin to understand now that the vertical component of the velocity when an object hits the ground, yes, y its initial velocity, yes, when it hit the ground, v, y its initial velocity is equal to zero. So you have v squared is equal to u squared plus 2gh, or v is equal to u plus gt, are both applicable. So for any vertical component of the velocity, note this, that when an object hit the ground, I've told you initially that v is equal to zero, so we need to know that. So the two formula that is applicable is v squared is equal to u squared plus 2gh, or v is equal to u plus gt. Yes, when an object hit the ground, So a vertical component the vertical component of the velocity when an object hit the ground v, while its initial vertical velocity equals to 0, is these two formulas is applicable. So how do we apply these two formulas? That's so essential. So let S be the distance from the foot of the cleft where the ball hit the ground. So note here that the initial horizontal velocity, which is u, is initial horizontal velocity is not affected by the vertical acceleration. That is, a is equals to 0. So you have s is equals to ut plus half at squared. So in this particular case, the initial horizontal velocity is not affected by the vertical acceleration. So we need to know that the initial is not affected. So what we are saying here is automatically, in this case, what you need to note in this case, so you begin to write them down, is x is equals to, basically ut plus half gt squared. But if the u is equals to 0, automatically s becomes half gt squared. Yes, half equals 1 gt squared. So what they are saying here is, note that if it is horizontal acceleration, yes, the g is equal to 0, horizontal acceleration. But if it is vertical acceleration, yes, it's not affected by the vertical acceleration. So basically what they are saying here is a vertical is equal to 0, but the body is under the influence of gravity, which is either plus or minus. So when you are working against gravity, your g becomes minus. Then when you are working to support gravity, your g is plus. So note this formula for us. And don't forget, v squared is equal to u squared plus 2gh. Then don't forget, v is equal to u plus a, which is gt. Then don't forget that when an object is projected, yes, projected horizontally, the u, when the object is at, before start coming down, is equal to 0. Then when an object hits the ground, the v is equal to 0. Okay. So please note this. We are going to see this application very, very soon. Okay, so let's move to let's see. Okay. So they are saying, yes, let the projectile be, the projectile be projected with initial velocity u at an angle theta to the horizontal. So we just explained this one. The horizontal component become u cos theta, while the vertical component become u sin theta. So if you remember, yes, if you remember, v is equals to u. So if you are moving against the gravity, it will become minus. V is equals to u plus gt. But in this case now, for the vertical component, then u becomes, no, for the vertical component, yes, for the vertical component, basically we know that for the vertical component, don't forget v is equals to u, there's minus gt, but for the vertical component, don't forget that. Then what happens to u? U becomes u sine theta minus gt. Yes. Then if the object is moving, when a ball is moving upward, you have this. But when the ball is moving downward, the Vy, when the object is coming like this, the Vy becomes U sine, which is the vertical. Yes, you see the same vertical component, but it's working with gravity. So this is only side that is changing. So if the object is coming down, it becomes plus. When the object is going up, it becomes minus for the vertical component. And the vertical component, yes, I told you when we started the vertical component that we can resolve this, yes, we can resolve this u in horizontal and vertical components. So note this is very, very important for you to note them. So it's very, very important for you to know them. Then when you move, okay, yes, then there is a point here. The height attained by the projectile height and T. So to reach the maximum height, something must happen. For you to reach the maximum height, the V must equal to 0. So you need to know that as well. So in this particular case, we say Y is equal to, don't forget, the Y is the height. So Y is equal to UT, yes, either plus or minus half GT squared. So what they are saying here is U has become, because we are still talking about the vertical component, then U becomes U sine theta T, yes, which is what is happening here. Using the formula of what x is equal to ut minus half gt squared. So we want to see what happened when the object reach the maximum height. So what happened when the object reach the maximum height? The something must happen there. So what actually happened? Okay, fine. So when you look at this, you have y is equals to ut. Okay, so let me use 10 here. So basically, what we're talking about here is, you still remember that we say s is equals to what? Ut minus, depend, plus or minus half gt squared. But if you are going like this, you are working against the gravity. So s becomes ut minus half gt squared. But now for the vertical component, Vy is equals to what? U sine what theta. So the y, which is the same thing as x, equals to, instead of u, it becomes u sine what theta, then times what? T minus half gt squared. That is how they got this. Yes. Then the time of flight. When we're talking about the time of flight, it goes like this. So the time of flight, it goes to this point. This time to reach the maximum height, then the time to come down. So basically, we're talking about a big T now. So you need to know that a big T is equal to what? Small t. So at this particular time of flight, the height has become 0. So that's what is happening here. Then t has become what? 2t. So that's what happened here. So instead of small t, it has become y equals to u big T sine theta minus half G, then T square. So they change it now, the time of flight. Now, so y automatically is equals to what? Is 0, because the height has gone to the ground. So the height has equals to 0. So if height is equals to 0, automatically we are going to have 0 is equals to u big T sine theta minus half what? G T squared. So if you make, yes, if in this particular case, so you can make what is going on here. So, or when you read the ground as well, so something must happen when you read the ground. So look at this particular thing. So 0 is equal to ut. So in this case, c is equal to what? Is 0. So basically, or t is equal to. So how do you get this? How do they get this? So that is the question. So in this particular case, you can multiply all 2 by t. So basically, if you multiply all 2 by t, okay, so what are you going to get? You are going to arrive at t is equal to 2u sine theta over g. So how do you get 2u sine theta over g? You can come like this. Look at it. I have half g t square is equal to u t sine what? Theta. So cos multiply. If you cos multiply, g t square is equal to 2u t sine theta. So divide both sides by what? G and t. T we cancel t. G and t. G we cancel G. One T we cancel T. Then what you have, big T becomes 2u sine theta over what? Over G, because this will have cancelled this thing. That is how they got 2u sine theta over G. So this is the time to reach the what? This is the time of flight, which is time to reach the ground. So you need to note that when it reaches the ground, something must happen. The height is equals to 0. So that's so essential. That's so essential. You need to follow up. This is so essential in this case. So that is how they got this particular formula. So this formula becomes time of, yes, time of flight. Yes, becomes time of what? Flight. So another thing here that we need to know is basically that what they are saying here. So from here, the maximum height now, you know, for the maximum height, you remember I told you that for maximum height, something must happen. So for you to reach a maximum height, so this is an object. So for this object to reach this particular maximum what? Height, which is h, to reach this maximum height, v must equal to 0. So if you remember, v is equal to u minus gt. Is working against the gravity. So v for the vertical, you still remember vy will equal to u sine theta. So if vy is equal to u sine theta, automatically v vertical will be u sine or theta over what? Gt. For vertical height, v is equal to what? 0. So if v is equal to 0, then gt will equal to u sine theta. So t will equal to u sine theta over what? Over g. So that is how they got time of what? Time to reach the maximum height. So time to reach the maximum height is basically, so the time of flight is equal to what? 2t, which is time to reach the maximum height. Because scientists believe that the time it's going to take to reach this place is the same time that it's going to take to reach what? The ground. So please, you need to know this as well. Do you get it, the logic?
Yes, sir.
Okay, fine. So we can move on. Okay, so we've explained this, then we've explained this. So please note this, that for the vertical component, yeah, we know this, that for the vertical component, Vy is equal to what? U sine theta. Then the time of flight is equal to U, 2U sine theta over G. So we know this. Now, so the height, so you remember V square is equal to U square minus 1, 2GH. So in this particular case, what is going on here? V is equal to what? 0. So if V is equal to 0, basically you know what we are doing. So what are we doing here? What we are doing here is this. V square is equal to U square minus 2GH. And Vy is equal to U sine theta. So automatically V square Y is going to give us U square sine square theta. So you can say V square is equal to what? U square sine square theta minus 2GH. So at this age, V is equal to what? 0. So 0 is equal to U sine square theta minus 2GH. So if you collect like that, this one will come here. So if it come here, becomes 2GH is equal to what? U square sine square root theta over, so divide both sides by what? 2G and 2G. So this one will cancel this. Then H becomes U square sine square theta over 1/2G. So this one becomes the height. So this one becomes the maximum what? Height. So at maximum height, what happened? The V is equal to what? Is 0. So if V is equal to 0, and the vertical component becomes what? Yeah, the vertical component here becomes U sine theta. So if you do all this, what you are going to get is H is equal to U square sine square theta over what? Over G. Is that clear?
Yes, sir.
Okay,
Yes,
fine.
sir.
So what is going to happen? Let me stop sharing because the thing will go off any moment from now. Then we can come back again.
Okay,
So
sir.
so far I'm doing the recording. Let me see.